Okay, so for each of these positions, and these, the ones that are constructed here, I need to check if those positions are not already known, as in yeah, well, made in less ply than what we're generating at the moment. So this is being generated, so we can find it in ply or less, then it's faster made, but of course it must always be per 2 to the same person as to move. I think it's ply -1 or less. Ply -1, ply -3, etc. But actually, yeah, who is to move is also important. Could split the map up in who's to move. Yeah, I don't think we win anything with that. Map is fast enough, isn't it? Well, that would save like 1 compare. I mean, nah. Let's not bother with that. Yeah, the person that is to play is important as well. Right, so currently I'm storing a vector, here, of maps, but it should become a single map. And rename this to nodes, I think. Just do it in parallel at the moment. So I have a node type, nodes. And yeah, this is just this thing here, nodes type. Oh yeah, man. You follow me often, I see, right? I keep seeing you. It's almost working. I think I'm pretty close. Just this refactor here. I'll show you the, because I guess you just joined. So I had a map with all boards, and then for boards that are made in n ply would be stored in this in the map that is part of this vector at index n. But now, yeah, then I have many maps. For every number of ply that the position is made, I have a different map. But I need to search for all positions. I don't know if it is made in how many ply. So I'm just changing this into a single map, and I'm going to have a vector that contains iterators to boards, and we are going to have a vector that stores vectors of iterators. I'm not sure about the name though. So the last vector, the vector of vectors, is maybe I should call this one made imply type, and this one I don't know, let's just call it boards or something. It's just a collection of boards, but it's for a fixed number of ply, so still what's in a name, right? Right, so this previously returned a map of all positions that are made in ply. And now we are going to have a vector. So it's just a boards type then. And we have to return the made in ply for that ply. And I'll just grow that one then. So made in ply is going to be the main replacement of data, I think. Well, it kind of depends, I suppose. But here I'm basically replaced data with made in ply. But the type is different. The type is now a vector of iterators instead of a map. Go to this do. This is the constructor. Obviously, we first have to store everything in the map, and then we have the iterator. So I need the map. It's just nodes. So this is going to be nodes. Yeah, that's exactly the word first here. I'm generating stuff here with mirrored. I mean, especially these. I think the second one, where mirrored equals 1, is always a duplicate in terms of the coordinates of the 3 pieces, and of course who is to move. Only the flip bit will be different. And flipped is not taken into account for the ordering or the comparison of boards in the map, which reduces the map size by 2. In other words, this iterator boolean pair can have a boolean that is false, as in it is not inserted. And I was going to say every position must be new, but that's not true. Iterator boolean pair dot second, that would be the boolean. That means that it was inserted. And then the iterator is obviously wait, it's not called data anymore. It's now called, this is my vector. So if the position was inserted, then this is the iterator, and we store the iterator in the vector for apply 0. I think this is correct. And yes, it is. But it being an iterator does not. It does not point to a board. It points to a pair, of which then the first is the board. To take that into account as well. And yeah, we don't have data. This must be then that vector, which is this one. So all positions that are already made in our map and made imply 0 vector. Good, yes. Let's see. The thing had a size 0, so now I'm making it size 1, so that index 0 is not out of bounds. Sorry, that's nonsense. Zero has to go. Yep, so we make the vector of vector size 1, so that now we have so that this index 0 is not out of bounds. And this whole thing is now an empty vector, which was just created here. And now we push back to that vector the iterators that, well, to the new entries in the nodes map that we just created. Looks now good. Data. Get the latest positions. Okay, this is ply, so that refers then again to, of course, the thing that we resized here, the made in ply vector of vectors. You see the data is more or less, well, a lot of places I can replace data with made in ply. Okay, made in ply positions is a map type, but I probably want to have a reference to the vector as well. Oh yeah, definitely. This is what you read from. That's why it is const. I really I'm not interested in the fact that it is a map. I just want to run over all positions, because these should be all positions that are made in ply. So this is definitely again made in ply then, with the ply index, and that returns a boards type. That is a boards type. Oh no, yeah, it should not be empty. It's not possible that there are no positions that are made in ply. Generate. Okay, there's also again related to the size compared to ply, so there's probably the made in ply thing again. And then this again as well. And here I have the number of made in ply minus 1 positions. No, same thing. It's lost data. So all positions that are made in ply apply in a new map, but in this case the map is always the same. So instead of new map, I should be using just nodes. And new map then becomes really made in ply. Place back, just and resize it with 1, make it 1 larger, which then is actually again that returns a reference to the new thing. That is again an empty vector with boards. I'm not liking the boards type thing, but it's a boards. It's also made in ply, but a single ply. So all positions that are. I'm gonna use positions in this case. I don't know. I should rename the whole board thing to positions anyway, but in this case I really want to have it. Positions, so let me do that here as well then. So this becomes positions. Towards iterators to positions. See? And where was I? I was here, I guess, line 171. Pretty sure that this is a positions type. Run over all positions that are made in ply -1. So obviously this must again be made in ply, which is then a vector of iterators. I mean, with index you get a vector that contains iterators. I think auto is often just too unclear. At some point you just don't know anymore what it contains. And it's better to just type in the real type. So this is obviously then the type of the iterator. I think that in the case of a vector, we might as well do it by value. So like, yeah, I mean, it's storing map. Sorry, it's storing... It's storing this, so just copy that. But maybe I should not assume that I think in debug mode iterators can be quite large, like 30 bytes even. But in the end, I mean, optimized mode, of course, an iterator of a vector is just a pointer. But yeah, I'm gonna add const reference anyway. I think it doesn't make much difference, but I don't really want to make any assumptions about the size. And using a reference when iterating over a container is just a, you know, normal habit, as it were. Now I got rid of all the datas, but it doesn't mean that it's going to work, because I also changed the names of a few variables. For example, we don't have value anymore. I now have iter. And then iter is an iterator to the map. So I do iter, and then that dereferences to the value type of the map, which is a standard pair of board comma data, and I just need the board. So first would be the board. That's the key of the map. And yeah, that's the current position, and also we just get a const reference. Other values of course are not used because I already converted it here to a current position, and we work with that. There's actually only a single thing lingering in my mind. I'm not so sure about this one. Well, it's just inserted, yeah. That I know of will not compile, and then I'll just start compiling and find the rest by compile errors. I think somewhere here I had yeah, this thing changed the type. So we have to look at the made imply positions when that is being used. So previously made imply positions was the map containing all positions that are made in the given ply, but I don't need that for the find. I mean, the find must be done in a map, so here we should just use nodes. Now, having a high apply means that it doesn't exist, because you start filling it with a 0, and apply 0, and then apply 1, and then apply 2, etc. So high apply is equivalent to does not exist, and it doesn't matter now that we look at all nodes, because, well, all nodes just includes not just then the current ply, but also lower plies. And yeah, who cares? This is actually a little bit slower now. Of course, you include all the lower ply positions, but well. And here the same thing. Doesn't really matter that. Just maybe I don't even need that variable then, because I want to use nodes all the time. Now here we don't have a nice comment. So what exactly is happening here? This tries. The comment is more or less here. Yes, also literally means it doesn't exist. However, I'm not sure. It's always a better move. Could also be faster. So if black can choose between going somewhere and then being mated in n-bly, or it can do go somewhere where we don't know the position yet. That if you go there, that's an unknown position, which means that it is made in a high apply. Oh yeah, well, that's the only thing that is important here. So if it is not n, then it could be correct, basically, that we only have the option to go somewhere where it is made in ply. Or it could be, well, no, because we now we look at everything, that we can have an alternate move where the black has even made it faster. in which case we should not reject that position, because yeah, well, black just wouldn't go that way then. So also here this condition should just check if anything exists at all in nodes. Could not find. Yeah, I'm just going to delete this. It's not really necessary anymore to print that. Yeah, and so I'm not really using this anymore then. Okay. No, I don't know. Hopefully it will work if it compiles. So yeah, let's make it compile. Undeclare identify node type. Yeah, I meant nodes type indeed. Of course, I meant nodes type. Int.js.cxx, I had not looked at that file. This prints the made in blah blah ply, so the ply is passed to the made in ply, which then returns us a positions type, const reference. So that would be dereferenced is going to be an positions type value type. Yes, but yeah, that's just an iterator again. It's not really a board either. Let's call it iter. No, not bad in the sense that it compiles on links. Now, hopefully it will work. It doesn't crash either. and it generates absolutely nothing. Okay. Oh. Let's go back to what did work, because this is a step back, but not really, because it was generating nonsense anyway. Applies 2 used to work. If I broke that, probably broke that, right? Yeah, you don't have anything anymore. Why not? Now, of course, if we don't have a ply in 1, then it will never find ply in 2 and never find ply in 3 and so on. So maybe the only problem is in finding all mate positions or something. We'll just have to debug this and see what happens in the constructor of graph for a start. Break main run. Let's the constructor here is going to generate all mate positions. I didn't change this, so the mate positions are still generated, all of them, so it's a lot. Let's go to break C7, continue, and then number of mate positions are, I don't know, let's guess. The board is now 8 by 8. I would guess 20. Oh no, way more, of course. All the rook, different rook positions. I'm gonna go for 90. 96, not bad. Okay, that is probably correct then. Well, it has to be, because I never changed that part of the code. Now it's doing nodes try and place. That should succeed, of course. So IBP must have a boolean that is true, yes. If IBP second, and that is true, yes, then we push back the iterator to mate imply 0, which exists. This should be a vector with size 0. And then after that it has a size 1. And then we do that for about half the positions, I think. So afterwards, as in break 4-8, it must be about half of 69, which is 48. It's 60. Yeah, well, okay. So I think that worked. So now mate implies 0 is a vector with 60 iterators, 2 positions. Looks good. So yeah, so my map now has 16 elements that are the 60 positions that are already made, canonical positions. And we have a vector here that has a size 1, where that only element contains again a vector with size 60, which contains iterators that are printed as dereferenced iterators for some reason, which are the same things as were stored here. Although here stuff is even more further. I don't know. Doesn't look the same. What does it? No, probably. So 60 is 60. No debug output. Annoying. Let's just turn it on. Graph generate. Maybe you can even see it in the debug output. What's going on? There are 60 positions that are made in 0 ply. Now even this one is rejected because obviously this would be a position that is made in 1 then. Although we can't reach this for, by a move of black. Black would just take the rook instead of go in the corner voluntarily. This definitely should not be rejected. And it adds it, like added adjacent board. Okay, so we're really seeing this as being positions that are made in 1 ply. And then why is that not ending up in preceding positions? That would be again 7 of them. And then we go to the next one. And so on. So it seems like totally working. Now, suppose it goes on till the end of preceding position, and then we have nothing. But they are generated, added, generate everything. I think I get it. I'm adding it to nodes here, and previously where I was adding it to a map whose size then was the number of positions that are made in that number of ply. But that role now has been taken by made in ply vector, and I'm not filling that. So that's simply missing here. I think I'm using try in place everywhere, so all of 2 places probably. Yep. And this one we did something indeed. I'm also storing it here. The exact same thing must be done down there. And that's the only thing that's missing. But then the 0 is of course not 0, but the number of ply that we are generating at that moment. Not sure if that is ply. And overall positions that are made in ply -1. Current position is therefore made in ply -1. It's also printed. And then preceding boards are 1 ply more. So yeah, that is ply, I think. No, now we have it. Made in 1 ply positions. So this is a made in 1 ply, because if you have this position and white is to play, then white goes here at the rook, and that's made. Same there, and there, and there, and there, and everywhere. So now made in 2 ply works again, hopefully. Or not. So it crashes on the board that was just printed, because this position already exists, which means that it is made in a very quickly, a low ply. And So that would be this one. I guess it found a mirror. So we flip this, the rook stays here, and then the white king comes there, and the black king is there. Can we find that? This one, right? Yeah, so this was already stored. We'll highlight this. Probably not working. Let's just highlight this. So this position is added, and then here it's the same thing but then flipped. Yes. Yeah, then the assert is wrong. What is the current number of ply? The ply 1 is generated, so I want it to be higher or equal. It's okay then. So if I find it, then I want to be sure that the number of ply that what we found is less than or equal ply. Not even this is being used. I'm not using mate imply at all in preceding positions, which makes sense. Nor apply itself. Like the sentence. Let's make this K. Hi, Sergio. I pronounced your name wrong, I know, but yeah, I'm not of the IDE. I guess I wrote my own IDE-ish, in the sense that I just use a terminal, but with a lot of bash functions. So this is NeoVim in console. I have a link for the syntax highlighting, which is also custom. I'll give you that link. I just have to go to your link, I think. But where is it? Yeah. And then I use bash functions. So let me say if I go to a certain directory, then the environment is determined by that directory. So I use different directories, of course, for different projects. And then I have And then those are automatic. The environments of those, the alias and bash function and everything is environment variables are automatically adjusted. So the only thing I have to do is type configure. In every project you go to some directory and I want to configure, I type configure. But in reality that's a bash function that does all the smartness. I don't have this online. I do have so my bash functions are not on GitHub. And while they are pretty extensive, I mean which I don't know, GS, which make, which VI. Nothing is what it looks like. So yeah, bash functions, the scripting, custom scripts. But it does help if you use my CDEH thing, for which is on GitHub. Except nobody can find it. What the hell is this? This one. I just linked this. Maybe it's not on GitHub actually. It's just here. You want this anyway in all circumstances. Even if you decide to use an IDE, then still you have to use CDEH as a developer on Linux. So my main, I mean, like I said, it's just, you know, it has grown over the decades, this stuff. But the main environment variables that I'm using currently is as follows. So every env.source for a given project, this is then the project. Start with setting a top project, which is not a repository. It's just something that ends in a directory. It ends in the name of the project. But the repository is usually one deeper. So the repo base is my variable that I use for the repository directory, which is then top project and then again that name. That's actually the Git repository. And then I have a builder set. And of course these four to know what to use when I commit to Git. And then yeah, no matter which build system you use, it's always handy to, or it usually works if you set CNCXX flags, and I definitely want to limit the number of errors to 2, otherwise you get flooded with nonsense. Useless nonsense. You always have to look at the top error anyway. So this way I have only, you know, to look at a little bit. And yeah, this is my current method of configuring using CMake. I set an environment variable, or this is also a standard in my case, so I set CMake config to one of these values. And CMake configure options is a bash array with the usual CMake defines. And not only since a month or 2 maybe, I need to set the CMake options configure string, which is just this line. Don't ask. It's also required. And then I use an alias S, which prints all the source files that I'm interested in. So I do a grep, then it's going to search in all these files. And if I do make ctags, it's going to ctag these files, etc. And then I make aliases as shortcuts for all the build stuff. But in order to have all these variables actually do something, then you need all the scripts, which are loaded by these two. For example, this is stuff for AICXX. So this grabs stuff, grabs all the sources. So this uses actually it uses PRS, but it's GPS, yeah. Project sources. And if I type GDB and then I'm actually doing this instead of GDB, which it internally calls GDB, but hey, sometimes it calls program with passing LT GDB. That's only useful for when you use auto, the GNU tools, I guess. To the what was LT stand for? libtool, yeah. And then all projects. So this is the main base for stuff that is just being used by me for everything. All projects. Set scholars. Get my key root. Makes abbreviations to CD to the repository or the build directory. Grab all sources. This one does use this. Set the compiler environment. That is the general configure, which works for a lot of different situations. And my general makefile. Oops. Yeah, just a mix hold off. That was it. So, I guess you could type it over if you want. Stopping the video and often. And in the meantime, I forgot what I was doing, or what was the last problem. I was editing, I think. Yeah. Oh, right, yeah. So I think that K is the... yeah, what is it? That's what this says here. So the latest, the complete collection of positions that are made in kply, where k is the largest value, such that they are complete is k thus. Yes, yeah, a lot of customization, yeah. You know, I code every day, 7 days in the week, and I've been doing this now for decades. And sometimes you just notice that you keep repeating the same thing over and over and over and over and over, and you get tired, or you get so old that your memory starts failing. In the beginning, I could remember everything, but at some point, I mean, if you have 50 different projects, you work on 5 different projects at the same time, and each has a different way to configure it. At some point, I just said, fuck it, from now on, I don't remember anything anymore. I just gonna type configure every bloody project, or if it uses CMake or Auto Tools or nothing or God knows what, because some projects use really weird shit. Then you have to do all kinds of things during configure. I just put all wisdom and everything I run into. If some point it doesn't work because something went wrong with configure, then I say, okay, how can I automatically detect this and then recover from it automatically? And then I put it in my script. So I don't have to remember it. Every wisdom is in my scripts. And then if I glance over that, I understand it again. At least till now. If I get another 20 years older, then I guess I will not. I can scroll over it and have no idea what it says, but it also helps, Sergio, that you know, it's like, how do I call that? If you have to learn for an exam for school, then one of the problems is that while you're learning, you're constantly thinking, oh my God, can I remember this? I have to remember so much. And then another page and another page, and your memory runs full. And you feel uncertain that you still know what you read 10 pages ago. So my trick at some point was that I would write a cheat sheet. So I would write, indeed, using a very small font. So I could theoretically cheat with it, just a little piece of paper. And I would write down everything that I needed to know, right? And then I never cheated. Because doing that resulted in me just remembering the whole cheat sheet. So then I actually knew it. It's just, yeah, I mean, but that was a good trick because you can concentrate much better. And that also applies for coding because if you learn new stuff, you Google something, you say, okay, I know this, but now I want to know that. I want to use this tool, or how can I do that? And you start Googling and you start reading page after page after page. And yeah, then also you think, yeah, but can I remember this? Is it worth my time? And it just really helps if you can put all your knowledge somehow in scripts. So one of my most powerful scripts is my, I'll just go here again, is this autogen.sh. It started as working for just Auto Tools, but it almost writes your project. You just start with an empty directory and you run autogen. It's going to say, you need to make a make file and you need to make this and that. And I already generated something for you and stuff like that. It probably doesn't do anything now, but if I run this, if anything is majorly wrong, then often I just run this script because it contains decades of wisdom to recover from all kinds of situations. That's why I made a joke that it starts like this. It even knows that it is me. Hey, Carlo, how are you today? And there were a few problems. So it fixed a few things that I didn't even notice that they were wrong. It also did a commit. This thing is smarter than the AIs of these days. But it's not AI, it's just a script that I kept adding on and adding on and adding. It tells me how to build the thing. Yeah, pretty cool, if I say so myself. This is part of the CWM4. So if you want to use that, then just look at a random project of me. These days I use these three for everything, basically. You could just use, in the description of the video, you have a link to the GitHub of this project. So you can just look at this project. And that then should point you to, actually it doesn't, I think. Well, anyway, if you are not a hard-working, investigative mind, then it's not going to work anyway. So you figure it out. You know, you can find my GitHub, and then you can find these projects as well, and you can then read the readmes, and it'll take a lot of work. I'm not saying these are the very, very best for a beginner. I don't know, it never caught on. So it's what I personally use in all my projects. But there must be a reason that some people, or most people, I don't know, apparently don't like it. I don't know. Works for me. But yeah, the autogen is part of this project. And you probably need to be the maintainer as well then. Like if I have a random person check out my project and they run autogen, because you have to do that after checking something out for Git, then it's not going to do a commit. It wouldn't make any sense, because you can't push to GitHub, to my GitHub. Yeah, it probably doesn't make any changes now I think about it. It just tries to compile the stuff as is. So it has to recognize you as the maintainer before it starts doing stuff like that. So you have to look at it and customize stuff and understand how it works, I guess. Now on the topic of AI, well, smart scripts. Now that's more related to programming. But I think it's as important that, let's say you are programming in C++, and you notice a way to make an error as the developer. So I'm writing code, and then later on I'm the user of my own code, and I made a mistake. So bug is introduced, and the bug is hard to find or not hard to find, doesn't matter. The fact that you were able to not understand the API, not understand the library of the code enough to make that error is annoying, because it costs time to find the bug and debug your program, etc. So every time that happens, I add an assert that will detect this error if you make it again, and add a extensive comment that I put above the assert that explains exactly what is going on and why and how you should solve it. That is also something you must absolutely do. My code is full with asserts. And now this is a stupid project that I just quickly do, but in most cases, if I have an assert, it is at least 5 lines of comment above it that explains, you know, why this can go wrong. I think in this case it's just a paranoia thing. This should never go wrong. So it's not trying to catch misuse of the program, but rather testing the consistency of the program under development. It's a different kind of assert. I mean, if this fires, then it should say this code is wrong. It's not that you made an error and you should solve it like this. No, it's like, what the fuck? I have a bug in my own code that I released I mean, the developer that wrote the assert made an error. That should never happen. In the end, I have bug-free code. My asserts never fire. If they fire, then you are using my code wrong. And then the assert should explain how to use it, how to use it. Even still, there's one comment. I mean, making an assert and without any comments. Oh, pain, the pain. If then it fires, then you skip 2 hours ahead at the very least. You have to redo everything. And just this one stupid line here already saved me 2 hours probably, or at least an hour. Well, maybe not in this case, but you get what I mean. And assert without a comment, no. They should make a law against that. But at least I understand what I'm trying to do here. And yeah. Let me actually fix it now. The problem is that you have a current board. That board comes from something. Wait a minute, no, the current board must be known. You can only ask for preceding positions if for the current board the number of ply that this current board is made in is already known. So I can very quickly get the number of ply by just looking at the size of that thing, but the debug code is just going to burn some CPU to check if it is actually correct. Because I'm not that certain about it at the moment. Meaning that I want to find the current board in nodes. So we are going to do this. Except then on the current board. And that will return an iterator, which I just store as, I don't know, iter. Assert iter is unequal nodes int because it must exist, and then we add a comment saying that only call preceding positions for boards that are from nodes. So if you call preceding position on a board that is not already in nodes, then you're doing something wrong, period. Not allowed. And having the iterator k must be equal to the number of ply. Okay, so iter points into nodes. That means that dereferencing it gives us the value type of this map, which is a standard pair of a board and data. Therefore, second will be data, and data contains not this data. Simply contains ply. Very boring. It doesn't contain much at the moment. So second is data.ply. Is that true? Because the idea was that when the latest positions that are already known to be made are made in k-ply, which applies to the current board. Yep. Which means then if we find this, so here new debug test, if def cw debug and if same thing. I'm going to find the JSON board now, and then I assert that it is end, like here, but apparently sometimes it isn't. So it's either end or the number of ply in which it is made is, I think, equal to k then. This happens, for example, because we only store canonical boards in the map, while I'm trying to insert all of them. So most positions have a duality, flipped or not flipped, and then one is added first, and then the second one runs into this problem that we find it. So I believe that we can only, that this should only happen once, but I'm not sure. But anyway, that's what I know. So that's what I'm going to type as comment. So now if this ever fails, for example, I don't know, this is not equal to k, then at least now I understand why I thought it should be equal, and then I have to rethink it. Maybe there's another position that is not a mirror. I could even add that if I find something that it is not, it should not be something else than the mirror of it. Because right now I can't really think of a position where that is the case. And in my comment I write that we are only talking about flipped positions. I mean, why would you otherwise find it, right? If I find a well, actually, the flip bit is not ordered for this map, so it is impossible to find anything else. So if it is not the flipped version, then it is a board that I really added twice, and I don't think that should be happening ever. Should it? Just can't think of anything. So if that is the case, it would be at the very least interesting to understand. So maybe I want to add an assert which tests that if it's not end and we find something, then this board is the flipped version. Well, this board was created with, oh, we don't know that. The magic happens already in the constructor, but I can extract it. So the only thing I accept is that flip bit is different. I'm highly doubting a lot here that this is not going to fire, actually. Yeah, that does crash. So I'm trying to add this. Trying to add this with the flip bit set, and apparently that was already added before. Or the K is even different, but I doubt that. No. Well, that would be a real bug. Yeah. Maybe we should check that first, actually. Okay, let's do it differently. And split this up into asserts. The lazy approach. But this should never fire, or we have a real bad bug. And then I can check this one again. Whoa, it does fire. So this is wrong. Applies unequal K. It's definitely something for the debugger then. Made in one ply with black to play. I don't think so. So K is wrong. This must be 2. Yeah. Why is K 1 then here? What is happening? Oh, should it be K plus 1? Here. We're entering preceding positions with 002022, which is 002022, with this position, which is made in 1. So board has ply 1, and this one therefore must have ply 2, which is whatever board is plus 1. But K is 1. I no longer know what I did here. Yeah, K equals the number of ply that the current board is made in. So we did it wrong. No, no assert. Still no assert. Very good. Okay, what do we have? Generate 3, 2, 1. There are 60 positions, I know. Just gonna go all the way here. Made in 3 ply. Before that was empty. This is the first time I get... No, it's not true. Before you had positions that were mate in less than 3 in this list. So if the output is correct, then I'm not even going to check all the debug output that led up to it. No idea how many there are. So how long is this calling going to take? Maybe I should have started checking from the bottom. Oh, there's probably a lot of them. Okay. How about 8 and 3 ply? Search for. Yeah, that's it. Okay, 8 and 3 ply positions. Yeah, that's correct. So the white king moves there, and then the black king has no other option than to go to the corner, and then we give mate. And it is not possible to give mate in 1, like before. Here as well. King moves there, and black has to go to the corner, and then we give mate. King goes there or there, and then black king has to go in the corner, and we give mate. And this one, well, try to escape there. So either the rook moves here, and then has to go in the corner and give mate, or the king goes there and must go in the corner and we give mate. Most importantly, you cannot give mate faster. I think it's mate in 3 or less is more or less already established. But here you cannot give mate in 1 because it just takes the rook. Same thing here, same thing here. And here you cannot give mate here because it just escapes. Same thing here, of course. Can give check, but it just escapes. So in this case, the rook must be moved to that square. It's the only move that's made in 3 ply. Again, rook here is the only way. Rook here, rook here. This is also an interesting one. You can of course not give mate, but you can retreat to one of these squares, and then king must go into the corner, and then it is mate. Same thing here, same thing here, same thing here, same thing here. Same thing here. Oh, wait a minute. That's, yeah, but not true. Same thing here. This is not the same thing. The king must be put there. Here too. But it's definitely not mate in 1 anyway. The king must go there. King must go there or there. Same with the one above that. Here you can move the rook here or the king there. King. Yeah, okay, so as long as the king is in the neighborhood here and the black king is 1 out of the corner, then you just force the black king into the corner and then give mate. Now mostly checking that it is not mate in 1. Otherwise I believe it. Yeah, I think we're past the point where it is, well, it's just clear now that this is working. Interesting. I want to have a situation where Check 3 is made in 2, right? So yeah, so we can have something where the king is more or less in the middle of the board. Let's say the black king is at 3, and then the white king is here, and the rook is there. Let's look for that position. It's a fun position. If you ask a child that question, then they can't find it. Well, often they can't find it. That's why it is an interesting position. So like this, but then shift it one more. I'm just gonna scroll down till the black king moves to 3, I guess. King went back to the corner. What's that? Why? That shouldn't happen, should it? It is made in 3. I just don't understand the ordering. I thought the ordering is by black king, by these diagonals. So this is a very early ordered thing, normally. Am I not printing this in the order that I find it in the map? I guess not. No, I'm not. I'm reading it from a vector, so it depends on which order this is added to the vector. Okay. Yep, there we are. Close with no cigar. That is called bastards. Can just search for it. I can just search for it. Black king. I want the black king there, and the white king. Let's put the white king at 4, also in the center. 4,2. And the rook at 4,3. Yeah, there is a fun position. Must move the rook there. And then the king goes there and he give mate. Okay, and what is the last one that was added? A lucky position. You just have to move it over here and then force the king in the corner and give mate. Pretty awesome. I'm gonna go to mate in 5. Mate in 3, I mean. So 5 ply. What the fuck? Still, you gotta be kidding me. Good, this is in 3 because king moves there, then the black king must move there, and then we give mate with the rook. Preceding positions. It's considering this as a preceding position with the black king there. Then black king could be so stupid to move into this mate in 2. Or it could do a smarter move. Or can it? No, it cannot. Maybe in the corner is smarter. No, yeah, I think in the corner it takes a long time. the longest time. You only have, well, this option and two other options. So from here it could go there. And then the white king moves here, and then you must go in the corner, and then it's mate. Or the black king could go here, but then... Oh, then we just move here, and you have to move back, and it's mate. So this thing should be added as, yes, it is made in 4 ply. No matter what black does, after that you have black in, you have made in 3 ply. However, we find it as being 4 ply. So it was already added, but it is 4 ply, that's correct. And it was added with the same flipped bit as before. Now that is interesting. That is interesting. So this position has been reached before. Maybe just moving the king from here to there. No, wait, black has been... Black, there was a last move of black. I guess assert is wrong, but I have to see it. Write this to a file, I would say. Where did it? Okay, so this position already exists with flipped off. So go from the top. There's a better move for black, rejecting. Okay, so this is not added then. This should not be added because it's rejected. And here we have another one. Now this is added. It's added and then mentioned as being an adjacent board. Just the same board. And flipped is false, so that's correct. And then why the hell does it keep mentioning it? Turn positions 1. Maybe it's still the same thing, so close. And then we crash. Okay, so it's added here. Why was it added? Because we consider the fact that we have this position, and now black might move there, and that gives us this position, and we added it because black does not have a better move, cannot escape at least mate in 4 ply. And I suppose that is true, because if you move here, so if you move here, then sorry, if you move here, then white moves here. No. No, no, it's starting from this point in the corner. If you go there, then white moves here, and then black has to go there, and then we give mate. So from here, black moves twice, here and there, and white moves twice, there and there. That's 4 ply, that's one more than these 3. And black did not have a better position, because we add this position. No, it's not. There's a better move. Okay, but this one then. This is adjacent to that one. So it could go in the corner. And then we have mate in 3 ply. 1, 2, 3. Or it could go to 2, 0. And then we move the king here and it has to go back and mate. That's also 3. Or it could go there, of course. And then we move the rook there. And then you have to go there and mate. Yeah. So there is no option for black that is better than going into the corner. That's why this was added. And here it's this one. And of course black also does not have a better option than going there. It's the only legal move. No, it's not true. No, it's the other way around. Sorry, black does this is the position. We go from here to there. So black can go here, but we already tested this position, right? Although before we approach this position when the black king came, sorry. Yeah, okay, now it's totally logical. So if you have this position, you can go there, there, or there, and all 3 are made in 4 ply. And therefore we will find this very position 3 times. From here, from there, and from there. And being flipped or not has nothing to do with it. The assert is 100% bullshit. Well, the flipped is 100% bullshit. I think this is not. I would almost type trivial here, but then I'm insulting everyone who's ever reading this comment, because it took me an hour to figure it out. It is also, it's definitely not trivial. Damn, what shall I type? Shall I type logical? I mean, once the insight came. Obvious? Oh, damn it. I think I'm going to type it because once I spell it out, it is obvious. Do I really try to avoid that? We get something like That's not working. Okay, so this is made in 3, not faster. Oh, I guess so. Well, the king must go up, that's clear. And then that king will go here, so he cannot give mate. You have to do a tempo move. Then has to go in the corner again, and then you give mate. White takes 3 moves here to give mate. No, that's a special one. It's almost made. Still not made in 2. Yeah, I guess the rook has to go here, and then the king walks along, and you can't give mate. Still needs a tempo. It's also fun. I think there's a lot of rooks here, and on the second one, and the king over here doesn't really matter, or on 1, what does it matter? You have to go to 2. Almost starts to look like a real game, huh? Where you are mating. Do you have to give check here, I think? And then if the king goes there, you go there, and then the king goes in the corner and you give mate. Or if the king goes there, that takes a move longer. So how can you give mate in 3 here? King here, maybe? King here. If you go there, it's immediately mate, so that's not smart. If you go in the corner, you just go there. That's the second move, and then it has to go back and mate. And if the king goes there, then you go there and you force it in the corner and mate. Yeah, king here is the only way to play mate in 3. Cool. And then this, of course, the same thing. King must go there. This is almost an actual problem. White gives mate in 3. Wow. Solution, king goes there. I'll have to try that out in a real chessboard. This is... What is this? Can I edit it? No, I cannot edit it. Board editor. Clear boards. King here. White king. Like this. White to play. Analysis. Yep, mate in 3. King c6. That is the only way to give mate in 3. The others were made in 5. Well, you have 2 possibilities. I solved this one, but yeah, that's another solution. pretty cool. Okay, so I think the program works. So now we can see what is the longest time that it takes to give mate in a board of 8 by 8. Where, well, you have to give mate, I think, in that corner, because the board is theoretically infinitely big. Nevertheless, I'm going to be lazy. I'll just try everything. 7. Ouch. Not working. Okay, so this is a mate in 5 position, which I believe immediately, but I'll test it anyway. Edit board. It's made in 2. Why was this added as made in 5? Apply. It's made in 3 ply. Ouch. How the hell can that go wrong? I think it was added as a mate. It was added as a mate in 5 because it was not added as a mate in 3. Or am I mistaken here? No. This is black to play. I need to go to white to play. Sorry. White to play here. This one is simply added as that's an adjacent board created on index 4. It isn't printed. I have this made in 4 position already. Mate in 4. Oh, king goes here. Only move. We can't give mate. Therefore, it's going to be for ply. We have to move the rook, for example, or the king. Go back mate. Yep, 4 in total. And then the question is, what was the last move of white? And we consider this position where the king stepped to the side. So we could go there and then we reach the position that is made in 4, right? Yes. And since white has nothing faster, but it does. Just a rook here. Oh, I'm only checking the king, not the rook moves. What? Okay, now I'm so confused. No, this position should already exist with should already exist as being made in 2, so 3. Rook check goes there. Oh, wait a minute, that's not made. No, it's not. You can give check, goes there, and then you still have to do a second move and a third. There. So this is made in 3. It's made in 2. So it says from this position we can reach the position where the king moves there, and then it takes a shitload of moves, therefore this is the previous position. Now, if white did not have a better move than going here, and then after that it is 1, 2, 3, 4, then this one must be 5. But it isn't, because the king could move there, and then it's just way faster made. So this should be rejected. Should it be rejected? It should be rejected. This position should be rejected, because it already exists. I think the problem is that this position was not added in. That is the problem. So if we go to apply 3, and we probably cannot find this position with white to play. I'm just going to copy this because there might be a flip here. I don't know, man. It's not there. It's totally made into. Rook 2, 3, king 2, 2. Yeah. Why is it not there? Turn on debugging. Still not there. I would. What? The debugging is not there either. What the heck? Well, this position is found from this position. So this position is, with black to move, made in 2-ply. Does that not exist then? Does not exist, not with black to play. Gets weirder and weirder. 2-ply is not working. Well, okay. This position is found by from here. Oh, what? No, wait. Oh, what? Huh? No, this is white to play. Mate in 1. Don't. This is black to play. Sorry, no, this is black to play? Yeah, this is black to play. Yeah, I think that maybe the problem is that the black king is on the main diagonal. But okay, I still have to see it for myself. This position does not exist. Where does it come from? That is king to 1, this position. We should find this position from... That's a good question. Black to move. I mean, this is the mate position. Last move of white is that. Last move of black is that. So this is a black to move position. This should exist. And it doesn't. Okay, and this one is therefore created from this position, I think. No. From this position. What? No, the black to move here. Then what was the last move of white? That is the question. Now this was the last move of white. This is the previous position. Huh? Nothing is found. Why? work. Oh, there it is. So what is wrong with my pattern? Oh, the bloody black king is at 0. Oh, it's not that one. And indeed it is still not found. Black king must be here. And it's never going to be shown? Right. That is never going to be shown. Yeah, we only have canonical positions, so the black king stays here. It's never going to be there. That is not necessarily a problem, I would say, if we could also find without problems flipped white positions with the black king on the main diagonal. I think that is the problem. 2-2. Therefore, instead of looking for this, I have to flip them, because this is not a canonical position. So it becomes 1-0, and then this one becomes 1-2, and this becomes 3-0. That one exists. So from here, of course, we find this position with the rook there, in the 2-ply one. Back to 5, why not? Okay, so the rook 3-2 with white to play. That is made in 1, yep. So now we put the king in the corner, and that's where it happens. Now we put the king and the black king back in the corner, and then we lose the flip information. So now just the white king and the rook can be flipped arbitrarily. So only one of them exists then, or I don't know, yeah, probably. Do we have black to play? So this one does exist. Made in 2. And then the white king to 2-2. With white to play, sorry. That is made in 3. Okay, it's still not 100% sure, but it is 99.9% sure. Well, 99. So I'm going to fix it. Where is that code? Black King. This becomes more complex. to redo the whole shit here. That's not true. Yeah, that no longer holds. Actually, it does hold. It does hold. This is canonical because white king is in the upper triangle. And here the black king must be in the upper triangle, therefore it had to be flipped. That's why the white king moved to the other side triangle. Well, I think that is correct, what I just did, but probably won't even compile. I said it compiled. Unfortunately, I think this assertion is just nonsense, right? Isn't it? How can I make this can I make this true? Generate all positions already made. White rook coordinates. Coordinate? What is WRC? It is white rook coordinate. Yeah. White rook coordinate is 2 till the horizontal limit. The black king is in the corner and the white king is at 0-2. That is not a canonical position. And 1-2 also not. So the white king here is never canonical. I want to make this a canonical position, so I just mirror it. That is 2,0 and 2,1, and then this must become also mirrored. And then since we add the non-mirrored thing first, and we add 2 canonical positions, and the mirrored ones are. I shouldn't even do this loop probably. No, I guess here the same thing, right? We will loop over mirrored, so the non-mirrored version must be canonical. Where kn is larger than 1, that is already canonical automatically. So now it should work. Canonicalized bool assertion mirror equals position was mirrored failed. Very interesting. I think I called that board channel. Turn it all on, except illegal. So I'm trying to construct a board 002233. Go right is the move. That's all on the diagonal. Just this one. Board is now 00223 white to play. Entering the board canonical is true. So we want to mirror this thing. Yeah, that's not gonna do anything. So we're not mirroring it because there is nothing to mirror. But we want to mirror it. Yeah, then you get this. Oh, you want to mirror it? Well, I didn't. That's basically what it says here. I guess that means it must be mirrored if we requested it, but only if not everything was on the main diagonal to begin with. So the position was mirrored only if mirror is true and not all pieces are on the main diagonal. So mirror and not on main diagonal equals position was mirrored. And I have no clue what the precedence is here, so let's just put probably necessary, those parentheses. And that solved it. Great. Now do we have, well, it doesn't even crash. Before we crashed, so it definitely gets further than before. And the question is, I suppose, do we have all correct stuff now as well? This is 5 plies made in 3. I have too many debug output, too much debug output. I'm gonna turn that off. Yeah, at some point I get a bit like, yeah, really do I have to check all this manually? It's not a fast way to check it. Could convert it to a fin code and then execute an external program maybe to obtain if it is made in. Yeah, this is an interesting one. Made in 3. Well, I see a made in 1. So why did it generate this? I mean, the board continues on that side, so it's not really made in 1 because there is no edge here. But then how did it get to made in 3? That's an interesting question. I think the king is, yeah, I think the point is that I'm not generating mate for this position. But the black king is not allowed to go off the board here. And that means probably just have to cut off where the king can go to. So it is no longer allowed to go there, because then it would be in check. And then the black king goes there. And then I move here with the king. And then the black king goes there, and then I have mate. So that would be mate in 3, yeah. I think that's how it goes. Well, all very interesting. Do we have, for example, I want to go to kings, like, the order is a bit unclear. It's actually made in 2, so that shouldn't be in here now. Yeah, okay, I don't know. Now I'm starting to believe that I can't really generate anything. So it would be nice if I had a way to check it, right? So every position, run a different program on all the positions to check that it is made in that many moves. But that would be a lot of work. Don't want to do that. Let's put AI to work. Yeah. That's early error. I have all debug off, I guess. What happens to OSS if the thing throws? Nothing, probably. I think it will just write the spaces and then nothing. No, nothing. Might as well not throw. Unfortunately. Wait a minute. Made in 5 ply. That is made in 3. Yes. Oh, they are all made in 3, right? They should be all made in 3. It's one of the more interesting ones, isn't it? King must go in front of the rook. It's the only good move. What's with the reconnecting? And why is it going up not made in 3? Can someone explain that to me? Or it just gives only 5 solutions, I guess. That is also pretty quickly made, isn't it? I can't move. What the hell? Why can I not do this? Cannot do anything. Practice with computer. Am I black? No. I'm white, but I can't move. That's maybe the reconnecting thing. Nothing that I reload didn't solve. Oh, actually. No, it's light chess down. Or something. Unreachable. Okay, let's go to the mate in 4 because why not? This is made in 4. It's made in 2, man. You're gonna be fucking kidding me. It still doesn't work. Oh, this is because the king is at the edge again. Yeah, it was made in 2, but yeah, yep, okay. So that maybe does work. You know, black king doesn't like to be in the corner apparently. Why not? I mean, you could just put the white king very far away. So let's look for a position where the black king is in the corner, as in black king 0,0. Yep, the white king is just pretty far away. It's made in 4, right? Should be. Yay, made in 4. I think this one is a cool one as well. I want to have one where the black king is at this edge and the white king as well. And then see what kind of positions are made in 4. So the black king is at something dot 0. And the white king is at something comma 0. And the rook, well, I don't care about the rook. What? Oh, it's flipped. Flip bit is set here. I should clear the flip bit, I think, by default for positions in the map. But okay, you can just copy this and now you still get it. Yep, meeting 4. But that the king is cut off like that is no fun. I want the rook to be somewhere there. So strongly I do care about the rook. Dot comma 1, is that possible? That is possible. That's a very interesting one, I think. Almost made, but not quite. Ouch! Ouch! It's made in 3. Ugh, okay, my program doesn't work. Seriously? And I have half an hour left until the shop closes. How can I eat anything? Oh, damn it, that's right. I didn't even have food yesterday. Yeah, I have to go to the shop to buy something.